Hi all, welcome to part 20 Logic System Design module 2. So this video lecture is dedicated exclusively for working out examples. So first you finish that till videos till 19 and come to this. Particularly this is a continuation of the concept we explained in detail at part 19. So it's just a continuation. So we are going to see the example and the theoretical background we built in part 19. So it's very important to understand part 19 and then follow this video. So let's see examples one by one. I just given the template. So we will start with, I'm just giving you the ones only in the notation and all. Directly I'm giving you the K-map. Sorry, it was highlighter. And you should know about the grouping. That is what we are interested. But at the same time, that term, prime implicant, everything we will discuss. Okay. So the grouping is what we are interested. So these are all the ones given. Okay. And if you can take variables in any form a, b, c. You can see that 0 0 0 1 1 0 1 1, then let it be 0 and 1, and the min terms. So these are all the min terms which are 1. Okay, and how to group them? So that is a question. So we will always try to get the largest grouping possible, right? So what we can do is see, one grouping possible is the largest grouping possible, and correspondingly we get the implicant, that is nothing but the prime implicant. So this is the first prime implicant I am getting. So when I am moving from here to here, B is fine, C is vanishing, A is also vanishing. So the entire thing, 4 elements are grouped, means 2 are eliminated, so remaining only one variable, right? And which is that variable? It corresponds to B. Okay, so yeah, A eliminated and C also eliminated. So what else? Now this one remains, and you can have a prime implicant out of it, or the largest grouping out of it. So it is nothing but, so this corresponds to, A is in the form of A dash, and B vanishes and C remains, right? So there are, now let me ask you, is it a prime implicant, this AC? So both are prime implicants, right? Both are prime implicant, and hope you don't have any doubt on it. So how many prime implicants are there? Are 2 prime implicants. Now tell me how many implicants are there. Just for your understanding, I am quickly telling you how many implicants are there. You can think of 1 2 3 4 5 implicants of 1 1, right? Or when you are grouping like that, 3 variable will be involved in each of them. So 5 are like that. So 5 plus now what about the 2 element grouping? This is one possibility, this is one possibility, 2 3 4 5. Am I right? Let me remove one element. Is clear to you, right? So there are 5 one element implicants plus, now if when I am looking at 2 element implicant number 1, implicant number 2, number 3, number 4, number 5. Yeah, that's all. 5 are possible. So again 5 2 element implicants plus, now what about the 4 element implicant? There is only a single 4 element implicant, right? So there are 5 2 element implicant and 1 4 element. So totally 11 implicants are there. 11 implicants are there, and but how many are prime implicant? So there is only 2 prime implicants. Okay. So totally there are 11 implicants. But anyway, this implicant concept is not, nobody is going to ask you, but they can ask you how many prime implicants are there. Okay. Now tell me which are essential. So is this implicant A dash C essential? So the requirement for an essential prime implicant is it should contain at least one min term that is not covered by any other prime implicant. You can see here clearly that if you are looking at this is special. This one is not covered by any other prime implicant except this A dash C. So because of this particular min term, right, because of this particular min term, I can say that this is a essential prime implicant also. So why it is essential prime implicant? Let me write due to min term. What is that? It is 1, min term 1, right, due to min term 1. Similarly, if I am looking at this B, the prime implicant B, is it an essential prime implicant? That is my question. It is also essential prime implicant. Tell me what is the reason for that? It is, see, if I am looking at this particular one, see, If I am looking at this particular one, it is covered by two prime implicants. So that is not the reason, but the reasons are like this one is covered by only this particular prime implicant. This is also covered by only this prime implicant. This is also covered by only this prime implicant. Because of these three ones, or a single min term is enough, I can say that this is a essential prime implicant. So it is due to so the reasons are like due to the min term, which is it? Okay, let me use this. There's some dark color. Due to min term 0, 1, 0, min term 2, min term 3. Sorry, min term 3 is not a reason because 3 is covered by two prime implicant. Min term 1, 1, 0, triple 1, min term 6 and min term 7. So all are reason that makes this be a essential prime implicant. And now you know how to write the final minimal sum of P. The minimal sum of product expression is write all the essential prime implicant, that is A dash C plus B, and just see whether any one remains. There is no one remains. So this essential prime implicant alone is making all possible all possible ones are covered by the essential prime implicant. So this is unique, right? So here you are getting a unique minimum sum of product because essential prime implicant alone covers all the ones in the particular K map. You don't have to depend on any other prime implicant. So it's fine, right? So that about it. We will see more example. Now, so the next question may be how many are essential prime implicant? There are two essential prime implicants also. They can ask a question in any ways. Now let's take another example. So here what I am doing is, let me write 1 here. Say 2 ones are here. I am randomly choosing some example and I am trying to see what are all the prime implicant, essential prime implicant, etc. Say A, B, C, D, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. Now how can I group it? I always want the largest grouping possible and I want to see whether it is prime implicant or not, or essential prime implicant, like that. So you can see that this is the largest grouping possible here. I started with it. I don't know whether it is needed or not, and let me tell you what is this. This is A, B, right? The other variables are vanished. Now what else? Now at this point, so what about this one? This one can you group with any other one? See, this is a term. You can't group it with any other one because there is no adjacent one for it, right? So this alone will exist as the as a term in the final minimal expression because you can't eliminate it, any of the variable from it. This is something like A dash, B dash, C dash, D dash. It should be there in the final expression because you can't make it a bigger group by adding any other one. It's not possible by folding in any other way. Okay. Now these two ones remains. Now one possible way that some people might think of is this kind of a grouping. Okay, fine, it is a largest grouping, right, containing two ones, and let me tell you what is the corresponding term. So A vanishes and B is there at top, C and D are there, right? Now another grouping possible is this one. So what is this? So this corresponds to B vanishes, A dash and CD, right? Oh, fine, yeah. So that about it. So this many prime implicants, all are valid prime implicants only because the criteria for a prime implicant is it is largest and no subset of it is having no superset of it is possible, something like that. At least one should be differently there, right? So if I remove any one of the variable from this, it is no longer a implicant. It is not going to imply the function, something like that. So those things you know. So all these are prime implicant. You can see that. So if somebody is asking you how many prime implicants are there, so there are 4, 1, 2, 3, 4. There are 4 prime implicant, right? So this is a prime implicant. This is also a prime implicant. This is also a prime implicant, and this is also a prime implicant. So there are 4 prime implicants, right? There are 4 prime implicants. So now how many are essential? That is the next question. So Fine, prime implicants are clear. But if I am asking you the question how many implicants are there, there are many. I am not going to count it because of all single term, two term like that. There will be many things that you can count yourself if you are interested. But it is not so an important concept. So from this point onwards, we will focus only on prime implicant and essential prime implicant. Now the question is this first prime implicant, this one is essential? It is essential, right, because it is containing a single one, and this is the only way of covering this one. You can't escape from it. This should be there in the minimum expression. So that is essential. Now, is it an essential prime implicant? So here also you can say that it is essential because this particular one. So let me tell you, this particular one, if you are focusing, there is no other way to cover this one. This is the only grouping possible for this particular one, right? So I need this one in the final minimized expression, so I should take this in the final expression. So it is essential for me. Now the next question is this an essential prime implicant? So let me ask you this before. Is it essential prime implicant? See, you can see that is also essential prime implicant. Why it is essential prime implicant? Because here there are many cases coming. See, this particular one, and this particular one. There is no other way to cover them. So this is the only grouping possible. But if you are looking at this particular one, there are two different prime implicant covering it, right? So that is not the reason. The reasons are the shaded one. So that is also the prime implicant. Now the question is the last one, that is this BCD. Is it essential? And you can see that this BCD is not an essential prime implicant. It is not an essential prime implicant. Why it is not an essential prime implicant? Because you know this the first one, if you look at this particular one, you can see that it is covered by two groups, right? So there is other ways also for getting it. This also covered by two groups. So if I am taking the other two group, I don't know how to put this group. So this is something redundant, right? It is not essential. But before finalizing whether it is redundant or not, let's write the minimum sum of product expression. So the rule is like you write all the essential prime implicants. So how many essential prime implicants are there? That can also be a question for you. So there are three essential prime implicants, right? So you can see them like say which are they. So this will be there definitely, right? There is no other way for getting that one. So that will be there. Then we saw that this which one? This A dash CD is also essential. That should be there. Similarly, AB is also essential. Now the question, do I need to write this BCD? So after taking these three groups, will it cover all ones or not? So the question, is it clear, right? So even if I remove this particular grouping, still the remaining things are covering. Even if I remove this particular grouping, still the remaining groups are actually covering the all ones, right? So I don't have to take it. So that is the thing. So what we concluded is like this one you don't have to consider in the final minimized expression. The essential prime implicants, all these are essential prime implicant. All of them uniquely identify the minimized sum of product expression, and no min term remains. So this is again unique. So right. So in these two examples, we are getting the unique minimal sum of product expression, but it is not the case always. We will see more example. Now this is another one. So what I am going to do? Let me write the terms. Say this is 1, this is 1. I am just randomly giving some value. I am just trying to see what is a minimal expression and whether it is unique or not, like that. See 0 0 0 1 1 0 1 1. You can write any variable name. Now 0 and 1. Now tell me what are all the grouping possible. So simply the prime implicant, if you are interested on the prime implicant, you can see the largest grouping, right? The largest implicant you focus, you will see that this is a prime implicant, right? This is another prime implicant, because you know the rule for it, and this is also because it is largest and none of its superset exists, right? So you can see that there are three prime implicants. So I am actually in the final expression, you can see the middle one is actually redundant. So you don't have to take it. But if someone is asking you the question like how many prime implicant are there, so that is why I am telling you that is also a prime implicant. Okay. So there are three prime implicants. That is the first observation I am having. and I'm trying to write down them like so the first one is like x dash y dash z is vanished, and similarly this one, is that marking clear to you? Let me write here. This one is actually you can see vertically the x vanishes and y dash z, and this one corresponds to x which is vanishing, y is vanishing, x is z. So like that 3 prime implicant we got 3 prime implicants, right? So you can see that this is a prime implicant and this is also a prime implicant, right? And this is also a prime implicant. Fine. So there are 3 prime implicant. And what about the essential prime implicant? You can see that this first one is essential also because I have this particular one, right? Now this one is not essential, but here this is also essential prime implicant, where this one is not essential. So why it is so? Which is making this first grouping essential? Because of this particular one, it is only covered by that prime implicant. Similarly, this one is making this one essential, but if you look at this one, both ones are covered by more than one prime implicant, so it is not going to be the essential one. So we don't have to, we can ignore it. So now everything seems sounds good, right? So hope you are getting more intuition on the concept when I am taking more and more example. So the minimum sum of product expression I am getting is the minimum sum of product expression I got like first I have to add all the essential prime implicant, that is x dash y dash plus x z. Now see whether any one remains. In that case only you have to go for the prime implicant, as the essential prime implicant alone cover all the ones. I am getting the minimum sum of product as the unique one. So there are only 2 essential prime implicant and they will cover all the ones in the K-map. So you don't have to. So the middle one, this is just redundant, right? Redundant. Let me write the term redundant. I can just ignore them, even though it is a prime implicant. It is not mandatory for me. Similarly here also this you can see that this is redundant. This is not mandatory for me. But sometimes you have to depend on it, provided some one remains, that you have to take care. Okay. So like that. Yeah. Now another example. So what can I take? So one here, one here, 1 1 1. Let us try to have a cube of 8 cells. Okay. Yeah, A B C D 0 0 0 1 1 0 1 1. Here also 0 0 0 1 1 0 1 1. Okay. So this is the kind of K-map I am having. So what I am going to do is I am trying to get the largest group. So definitely everybody will be choosing this first because it is largest, right? And it is the prime implicant, the first prime implicant I am getting. You can see that across the rows A and B vanishes, and across the column, the last 2 column D vanishes and C remains. So this entire thing corresponds to the prime implicant C, because you know 2 power 3 8 cells, that is 2 power 3 cells are grouped, 3 variables are eliminated. Out of A, B, C, D, 4 variable, 3 eliminated, only 1 variable remains, that is my C. So I can see that this is a prime implicant. Now what else? Now another largest grouping possible for me is this one. You can see this. See, covering the remaining ones and all. What I got is, it is something across the column C and D vanishes and A, B remains. So A, B dash, like that it is. You can write it, right? Now what else? Now these 2 ones are remaining. Now tell me what kind of grouping you can do. The largest, only this one remains actually. If you are writing like this, this is an implicant. If you are writing like this, this is also an implicant. But what we need is a prime implicant, right? Prime implicant means it is largest possible, right? So the largest one possible is by folding. You can fold these 4 ones together. Just for this one, I was doing like this, right? And I am getting it like from the across the rows, B vanishes and A remains, first and last column. C vanishes and D remains, and it is 0, D dash, right? So I am getting 3 prime implicants. 3 prime implicants. So all are prime implicants. Fine. So all are primes. Now this is clear. Now is it essential prime implicant? That is my next question. You can see that this is essential due to this particular min term. Okay. And similarly, this largest grouping, that is also essential due to many terms are there, right? Essential prime implicant, and this is also essential prime implicant. And tell me the reason for the essentiality which is making them essential. For example, if I am looking at AD dash, if I am looking at this AD dash, you can see that this one is actually making it essential, because all other ones are covered by more than one grouping, but this one is covered only by this AD dash. So exclusively it should be there in the minimal expression. So that is what is making it. Now if I am looking at this AB dash, you can see only this is making it essential, because in that grouping others are covered by more than one and similarly here there are many. So this one, this one, this one, this one, this one, all are covered only by that particular 8 element group, no one else. So all of them together make that C as essential prime implicant. Right, now it is clear, right? Now what are all the conclusions I am having? So if you want, you can count the implicants. Right now I am not counting implicants, but what else? How many prime implicants are there? There are 3 prime implicants, right? How many are essential? There are again all the 3 are essential also. So how can I write the minimal expression? So the minimized expression, that is minimal sum of product expression, is a combination of all essential prime implicants, that is AD dash plus AB dash plus C, right? So that is going to give me the, and it is unique also, because here also okay, the different way, in the previous video we saw an example, so that where we saw that the prime implicants are actually there are certain prime implicant which are not essential prime implicant also getting part of the minimized expression, and accordingly we are not getting the unique one. But all these example till this example 4, they are unique examples. Fine. Now the next one. So I am giving more and more example for making the concept clear to you. Fine. So what is this? What we taken here? Okay. Something like 1 1 1 1, and there is a 1 here, something like this. So A B C 0 0 0 1 1 0 1 1. Here it is 0 and 1, like that. So can you tell me the grouping possible? So now it is very easy. For a smaller example, you don't have to spend much time. So this is the largest grouping possible, and another one is like to cover this one, I can group it alone, or can I make it a 2 element group? Yes, it's possible. I can't make it more than 2 element, right? So 2 a grouping I got, and I know that both are the prime implicants. The first prime implicant I am getting is A vanishes, and B dash, this only B dash remains. C also vanishes, and here what is the term corresponding to this? When A is like this, first column to last column, B vanishes and C dash remains, A C dash. So I am getting 2 implicants which are prime. So I can see that both of them are prime implicants, right? And what about essentiality? Both are essential also, because why this is essential prime implicant, you can see. Similarly, why this is essential prime implicant. Okay, let me mark you the reason also. The reason is certain min terms. So if you are looking at this grouping, which are making it special. So it is special because of this one. Sorry, which color I taken? This is special because of this one, and this one, because these 3 ones are covered only by that grouping. But I can't take it because it is covered by 2 different grouping. Now this one is essential because of this one, right? Hope it is clear. So now the conclusions are like there are 2 prime implicants, and there are 2 essential prime implicants. Both are essential. Okay. Now the minimum sum of product expression will be like a B dash or AC dash, and it is unique also. So this example also unique. Now I think shall we see in the next video, or a few more examples we will cover in this only. Yeah. let's go a little bit faster. So the next example is like example 6. So let me write A B C D 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. So the elements are like I'm filling this way, then here elements are coming. See, these are all the minterms. Okay, so the right side it's filling mostly, right? Now I am trying to see the grouping. I can see the largest grouping possible is one grouping is this. Fine. So is it essential? That is my question. You can see this one is covered only by this. So I can directly write all those things now. So the A and B vanishes and it is something like a C D dash. Now what else? Now you know this 4 ones you can group, and there is something that is making it essential, this one, right? So this corresponds to what? This corresponds to that A vanishes and B remains, C remains and D vanishes. Fine, BC. Now what I can think of is I can have a group like this. This is a prime implicant, right? I'm just looking at prime implicant only. Next level I will see whether it is essential or not. So A is there, B vanishes, then 1 C is there, D vanishes. Fine. Now let me tell you, these 2 ones remains and the largest grouping possible is this one. And what is the corresponding term? Again A is there, B vanishes, and 0 to 1 C vanishes, and D is there. So this corresponds to AD. Now the question is to find out the essential prime implicants. See, you can see that all these are prime implicant, right? There is no doubt on it. So all these are prime implicants. Fine, all are prime implicants. So there are 4 prime implicants. I got 4 prime implicants. So this is a question, how many are there? They can ask you. Okay. Now check whether they are essential or not. So if I am looking at this is essential because of this one, right? So this is essential prime implicant. Similarly, this is essential because of this one. So that is also essential prime implicant. This is also essential because of these 2 ones. This is also essential prime implicant. Now what about this? This is not essential prime implicant. So that is observation we are having. This is not essential because all these ones are covered by other prime implicants. So I don't need it as essential in the final grouping. So I can just tell you which makes this grouping essential. So here this one is making it essential. Here in this group this is making it essential. Here in the last grouping these 2 are making it essential. But if I am looking at this whole thing, I mean this whole group, it is not essential. Why? Because if I look at this one, you can see 2 grouping, here also 2 grouping, here also 2 grouping, here also 2 grouping, right? So that is why it is not essential. Hope it is clear. So only there are only, out of the 4 there are only 3 essential prime implicants. And let me write the final expression using some. So the minimal sum of the minimal sum of product expression will be essential prime implicant. Write down them all, C D dash plus B C plus AD. So this is unique because by all the essential prime implicant, I mean without AC, this is covering all ones. Okay, so I am just getting a single one. Yeah, hope it is clear. Now the next example. Here what I am going to do is, let me take like A, B, C, D, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. So I am filling them like 1, 1, 1, 1. Here let me take 1 here, 1 here, and a 1 here, 1 here, and 1 here. So this is what I am having. Now I am trying to see the grouping. So what I can see is the largest grouping I want, right? So this is one grouping possible, these 4 ones, I can't make it 8. Okay, so these 4 ones together, what it is, A and B vanishes and C dash D dash, it is like a C dash D dash, that is this grouping. Now what else? So I can think of a prime implicant like this. Fine, because it is largest grouping, that only I have to worry about, because here you can see that A vanishes and B remains, and across the column C D vanishes and C dash remains. Fine. Now what about it? These two ones, the largest grouping possible out of them is the corner group. I mean, these two ones you can group, but you can make it little bit bigger by considering these two corner ones also. So all the corner ones together is making this last grouping, and you can see that here. First row to last row, A vanishes and B dash remains, and first column to last column C vanishes and D dash remains. So this is B dash D dash. Now this one remains, right? So how can I make a group out of it? What I can do is just two element grouping is possible, nothing more, right? So you can see definitely only one variable is eliminated. So A and B remains, and across the column 0 to 1 C vanishes and D remains. So it is A, B, D. Now what about whether they are essential or not? So this is all these are prime implicant. Without any doubt you can write them all as prime implicant, prime implicant, prime implicant, prime implicant. So the conclusion is there are 4 prime implicants. Fine. Now what about the essentiality? So if you are looking at this particular grouping, is it essential? You can see that this one, this one, this one, this one, all are covered by more than one prime implicant. So this is not essential. This is not essential prime implicant, right? Now what about this one? This one is making it special. This one also, right? So this is an essential prime implicant. Fine. Now what about this ABD? That is also essential because this particular one, right? This is also an essential prime implicant. And what about this one? Which grouping it is? Sorry, what I made a mistake actually. Actually this was essential because I thought that this is a vertical one. Vertical one is actually C dash D dash, that is written here. This is not essential. This is actually essential. Okay, that I mistakenly taken. Fine. So you can see that there are 4 prime implicant and 1, 2, 3. There are only 3 essential prime implicants. Fine. So again let me give you the reasons so that it will be more clear. So which is making this one essential? This B dash D dash, this one and this one together making that grouping essential. Others are covered by 2 people, and similarly this one is making BD essential, sorry, ABD essential, right? This is essential because of that shaded ones. Okay, now what else? Who is making this BC dash essential? It is by this particular candidate. So that's all. Now what else? This one is not essential because the ones are covered by other people. So I don't have to worry about it. So if you are going like this, the minimization, minimized expression writing, everything is all are very, very straightforward for you. Okay. So the final minimal sum of product expression is again the just write down all the essential prime implicant, the B, C dash or B dash, D dash or A, B, D. This C dash, D dash alone is not essential. You can eliminate it and you will be getting it as unique because they cover all the ones. Example 7, maybe a few more examples we will take. So finally it has to be clear to you. Okay, so just for you I am taking this many examples. Now this is say A, B, C, D, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1 like that. And once I am feeling like a see 1, 1 here, 1, 1, 1, 1 here, here also I am feeling. Now let me find out all the prime implicants first. Now you can do it a little bit faster, right? So these two ones you can group like this. This is the first prime implicant I am getting, right? So what is this? This one corresponds to 0 to 1, A vanishes, B dash, 0, C dash, D vanishes. Fine. Now another grouping is possible for me is like this. What I can write, this corresponds to A column wise C dash, A C dash. Fine. Now another possibility is like yeah, everything is very clear to you now. So this particular grouping, this also here you can see that A is there. So A vanishes, B is there, C is there, D also vanishes. Fine. Now you can see that this is also a prime implicant, but by this time you will not take it because you know that it is not essential, right? But just for your for the completeness I am taking, if somebody asking you how many prime implicant are there, you should know that this is also a prime implicant. This is my AB. Right, because it is the largest one, that is only requirement, and it is an implicant also, right? So it's a prime implicant for sure. See, that's all. So what I can do is I can now write down all the prime implicant. This is a prime implicant, this is a prime implicant, right? This is also a prime implicant, and this is also a prime implicant, and you know that there are 4 prime implicants in this example. Now out of them how many are essential, that is the next question. So if you look at this this particular one, you can see that this is essential prime implicant because of the top 2 ones, right? Essential. Now if I am looking at this particular grouping, see no one is covered by exactly one prime implicant, something like that. Everybody is overlapped with the 2 more prime implicant like that, right? Fine, this is not essential, this is also not essential. So this is AC dash is not an essential prime implicant, and this group also not a essential prime implicant. Okay, now what about this? This is essential. This is essential prime implicant because of the top ones. So let me tell you what makes them essential. Let me highlight them. You can see that if I am looking at what is the first essential prime implicant I am getting, it is this one, right? This is essential. Who is making it essential? Due to the color I find difficult. Yeah, this one and this one, they are exclusively covered by this particular prime implicant. So that is what makes them essential prime implicant. Clear? Now if I am looking at another essential prime implicant, which is this one, you can see that this is essential prime implicant because of this one and this one. You can see that it is exclusively covered by only this prime implicant. Now why this is not essential prime implicant? Because see, this is covered by 2 ones, this is covered by 2 prime implicant, this is also, so it is not essential. Without this also I may get the minimal expression, I may get, okay. And similarly this also not essential because you know all ones are covered by others also. So here it is a different example where you, out of the 4 prime implicant only, see out of the 4 prime implicant only 2 are essential, only 2 essential prime implicants are there. Now what about the minimal expression? So if I am writing the minimal SOP expression, first I have to write all the essential prime implicants. So I am getting them as the essential prime implicants are B dash C dash is one. Now BC is another one. So now the question is, will it cover all the ones? So if I am taking B dash C dash, which are all the ones covered? So if I am taking B dash C dash, if you want I will show with the help of the highlighter. If I am taking the essential prime implicant, you know this one is covered, this one is covered, this one is covered, this one is covered with that B dash C dash. Now with this BC, these 2 ones are covered. Now the problem is I want these 2 ones to be covered in the final minimal expression. So for that I can either depend on this particular group, I mean what is this square? This square is my AC dash, or I can depend on AB. So both will give me the final minimized expression. So right, so that is important. I am removing all. Fine. So the important concept here is the minimal expression. If you want to get the minimal expression along with the essential prime implicant, one possibility is you add this AC dash. You know, by just look at all the terms covered by them, you can see that all ones are covered by it. So this is one way. Now another way is like you can, instead of this AC dash, you can depend on AB. Okay, so that means the remaining terms are there as it is. The essential prime implicant will be there, but the last term you are getting 2 choices. So both are valid. So it is not unique. So now you are not getting a unique minimal sum of product expression, and you know both of them are correct. So this is valid and this is also valid. You are getting 2 different minimal sum of product expressions. So that is the speciality of this example. Hope it is clear. Why you are getting 2? Because essential prime implicant alone is not covering all the ones. 2 ones are remaining. And those 2 ones either you can cover with AC dash or AB. Both are fine. So any one of them will come in the final expression. Fine. Yeah, if you want, you can number the prime implicants also. In that way also you can tell the answer. So hope it is clear. This is important because here you are getting 2 prime implicant, and with that you are not able to cover all the min term. So you are getting more than one minimal sum of product. Both are valid. So now that also can be a question, can be a valid question. How many minimum sum of product expressions you are getting? Most of the cases in the example till 7 we are getting only one minimum sum of expression, product expression, because it is unique. The essential product prime implicant alone is covering all ones, but here it is not the case. It is different, right? Hope it is clear. Now what about okay, let's take 2 more example. See, x, y, z. This is like 0 0 0 1 1 0 1 1, right? Here it is 0 and 1. Now a1 here, a1 here, a1 here, a1 here. See, now how to group them? Grouping. Yeah, largest grouping possible. This is one grouping possible. This is another largest grouping possible, and by the folding method this also possible. So 3 groupings are possible. Accordingly I am getting 3 prime implicants. All are prime implicants. Fine. So you can tell me what are they. See, this one corresponds to x dash, y vanishes, and z dash. Fine. Now this one corresponds to x, y dash, z vanishes, and this vertical one, this one corresponds to x vanishes, y dash, z dash, right? Now the question is whether they are prime implicant or not. You can see that all these are prime implicant. Fine. This is also prime implicant. Fine. This is also prime implicant. Now whether they are essential or not. When you look at this this one, you can see that this is essential prime implicant for sure, because this one is exclusive. And but when you are looking at this is not essential, right? You can see that here the ones are covered by more than one prime implicant. So this is not a essential prime implicant. What about this? Here this is essential because this one is covered only by this. So which are making them essential? So this is essential because of this one. That is what I was trying to say. And now this is essential again. This is essential because of this one. You can see clearly that it is covered only by that particular. But if I am looking at this one is covered by 2 grouping. This also covered by 2 1. That is why it is not essential. So what I can conclude is, see, I am getting 3 prime implicant, and out of them 2 are essential prime implicants, right? So this is what I obtained. Now the minimum sum of product expression, just try to see whether essential prime implicant alone is sufficient or not. Essential prime implicant, the first one is say x dash is a dash, plus another one is this x y dash. They are essential. Now if I am taking these 2, I am getting all ones covered, right? So I don't have to depend on the third one. So I am getting a unique minimum sum of product expression, right? Now let's take one more example and we will wind up. So 10 questions we worked out, right? Fine. A, B, C, D. 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1, and let the ones be like here and here, something like this. So this many ones are there. So what I am going to do is, as usual, I am trying to form the largest grouping possible. Now the corner ones all together I can cover by a this one. Let me use a different color. First let me write this. So what is this? This corresponds to the 0 a dash, B vanishes, C dash, A dash, C dash, A dash, C dash, D also vanishes. Now the corner ones, you know, this one, this one and this one. When you fold, you will get together as adjacent ones. You know that this whole thing corresponds to what? First row to last row, 0 to 1, A vanishes and B remains B dash. First column to last column, 0 to 1, C vanishes and D remains D dash. C vanishes and D remains D dash. Okay. Now what else? See, only that, these two, and you can see that both are prime implicant and essential prime implicant. Now it's very straightforward for you, right? Both are prime implicants and essential prime implicant. I was just taking some random examples, that's all. Yeah, anyway, the concept is very clear to you now, right? And you can see that this one is essential prime implicant because of this one and this one, because all of them are covered by only one prime implicant. That is what make them essential. Now similarly, this is essential, again 3 ones are making this essential. Clear? That's all. So what you can see, there are 2 prime implicants and there are 2 essential prime implicants, and the final minimum SOP expression is A dash C dash plus B dash D dash, and it is found to be a unique one. Fine. So we saw many examples. I think even I am also exhausted by teaching you this many examples, but finally it has to be useful for you. I don't know how many of you are seriously taking this example and all. See, by this what we can conclude. So the thing is that if you just take the question one by one and try to, even though you are going with the video lecture and all, just draw the diagram alone and try to do it yourself and see whether the answer is matching with what I am explaining. Sometimes I may also make mistake, I don't know, simply the same procedure I am doing repeatedly. So maybe different example, even if you find any mistake which from my side, you can correct me also. Anyways, one or other example, I just want you to clear this idea, right? It's very, very important concept in digital electronics, right? Because it is a base for minimization. Once you get the expression minimized, the corresponding implementation, the circuit will be minimal one, right? So that is what we need everywhere. So that is why every time we are looking for, we need things of minimum size, right? Yeah, that's all. Thanks for watching.